the transistor as amplifier. In that we have studied that the transistor amplifies the weak signal into strong signal. When we fed the weak voltage signal, that is weak alternating current, that will become strong alternate current output. By using the transistor, we have made the amplified the signals. Today we will study transistor as an oscillator. So first of all, we have to know what you mean by oscillator. What do you mean by oscillator? Oscillator is a device which produces undamped electromagnetic oscillations. So remember, oscillator, it is not your mechanical oscillator, but it is electronics or electrical oscillator where electromagnetic energy oscillates. Like here, it is a device which produces undamped. Undamped means you already know, whose amplitude do not decreases. Undamped means is undamped vibration, or undamped oscillation means whose amplitude do not decrease. If the amplitude remains same throughout its distance, then such kind of oscillation is called as undamped. So when any such devices which produces undamped electromagnetic oscillations, those devices are called the oscillators. So we are kind here with one of the oscillator. Like if we consider, I am just taking an example, if we consider one capacitor and one inductor circuit, one capacitor and one inductor circuit. So it is a C and it is the inductor L, or you can also write it as a T or something. See, it is a capacitor. When this is get charged, let us assume that the upper plate is positively charged and lower plate is negatively charged, then current starts flowing through this coil, you can say inductor. Now here, in this capacitor, energy is stored in the form of electrostatic energy. When that electrostatic energy comes to the inductor, that energy is converted into the magnetic energy. So inductor produces magnetic field around it. When current starts flowing through any coil, which produces the magnetic field. So when the electricity goes through this one, it produces a magnetic field. You can say that electric energy converted into magnetic energy. Further, this magnetic energy is suddenly not created. It is go on increasing from 0 to maximum level. While it is increasing from 0 to maximum level, there is a change in flux linking with the same coil, or you can say same inductor. Then process of self-induction takes place. Due to self-induction process, the current is produced in this coil, and that current flows through this circuit and the charges accumulated such that here in the second cycle, here positively charged are accumulated and here negatively charged are accumulated. Now, initially the current direction was like this, and charges are discharged from the capacitor while current is in this direction. Now, when the reverse current is generated in this because of the change in magnetic flux linking with this coil, then the charges are accumulated like this. So here you can see one beautiful phenomena, that here electrostatic energy is converted into mechanical energy, magnetic energy, and that magnetic energy further get converted into electrostatic energy, and hence go on conversion is taking place. Electrostatic energy, magnetic energy. So this conversion of energy is nothing but the oscillation of energy, or you can say electromagnetic oscillation. So if you consider here this wire, you can say here some losses will take place in the form of heat. Due to the resistance and all, some losses takes place. Whatever the energy is converted, initially the energy was like very high. Like electrostatic energy, when it passes through, it's maximum. So it is maximum. When the magnetic energy, this flux produces the electric current in the negative direction, due to the losses, its amplitude is decreases. And further, here initially 90 charges are there. Second time, due to the change in magnetic flux, whatever charge developed here, they may be 70. So only 70 charge takes place in the current developed. So still the amplitude go on reducing and reducing. So here you can see the amplitude of energy, or you can say amplitude of electromagnetic oscillation go on reducing. So this is not the undamped oscillation. This is not the undamped oscillation. If you want to get the undamped oscillation, then the amplitude of the the oscillation must remain constant, but here it is not constant, so we cannot say that this is undamped oscillation. So how to prepare or how to get the undamped oscillation is, see, undamped oscillation can be formed by taking first an amplifier circuit, transistor as an amplifier circuit. So first we will understand the basic theory regarding this. So if you take the amplifier, transistor amplifier we will call amplifier, and we fed some input to this, and it is input, I am calling this as the input. So this input is becomes maximum, or you can say amplified, and you will get an output. So if we take this output on a regular basis, if we check the output on regular basis, then its amplitude is gone decreasing. So to maintain the amplitude constant, we have to have some amount of the output signal is fed back to the input. So that is done by a device, or you can say this process is called as the feedback. So feedback signals or feedback process makes the oscillation undamped. So how it makes means, whenever the decrement, or you can say whenever the amplitude decreases, it sends the signals that input must be increased, so that we will get the same amplitude as the output. So how it works and how the things working out here in the transistor as amplifier, you will see through this diagram. So here you can see we are using a NPN transistor. This is what the NPN transistor is, and in the NPN transistor, this is the N, and this is the P, and this is the N. So here the arrow mark is there, so it becomes emitter, and this becomes collector, and this becomes base, right? And this is what the transistor, you are already familiar with that. Now what extra we have connected is between E and C junction, means emitter and collector junctions, we have connected a tank circuit. This is what a tank circuit is. So tank circuit means what? A circuit which is composed of capacitor and a induction coil. So capacitor and induction coil, and we have named that induction coil as a T1, right? So let me recall it. Collector and emitter junction is connected with a tank circuit. This is what the tank circuit is. I am naming here somewhere. This is what the tank circuit is. So tank circuit includes capacitor and inductor coil connected in parallel. These are connected in parallel, isn't it? These are connected in parallel, and one key is connected here. One key is connected, and also a supplied voltage is connected. So this is P, yes, key is connected, and being this is collector side, this voltage becomes VCC, and being this voltage at the base side, this becomes VB, right? So this is regarding the collector and emitter base junction, sorry, collector and emitter junction. Now base, and see, this wire goes like this and comes back like this, right? So between base and emitter junction, there is another induction coil connected, that is T2, and this B and E junction connected with the voltage or supply, that is VBB, potential difference. So this is regarding the construction, basing the constructions we have to. Now in detail, if I explain, you can see here base emitter junction is in forward bias condition because P is connected to positive of the battery and N is connected to the negative of the battery. Hence base emitter junction is made forward bias condition by VBB battery after passing through the coil T, and collector emitter base junction is connected in a reverse bias condition to VCC battery. Here this must be connected to positive, I guess. Here it is in reverse bias condition, means this must be connected to positive and this must be connected to negative. VCC. Now you can see here, this collector is connected to positive and it becomes N is connected to negative means it becomes reverse bias condition. So this collector emitter junction is made in a reverse bias condition by connecting a tank circuit between them, and a switch is connected to turn on and turn off the circuit. And one more you have to remember, one more point you have to remember here is this coil T1 and T2 are wound on the same core, means they are connected to same core. If it is a core, so iron rod or soft iron rod, one coil T1 is wound here and another T2 coil is wound here. So on the same core, these two are wounded. So here I am showing that magnetic field or flux like this. So this indicates the mutual induction. Now, so this is regarding the construction. How it works? How it works means you have to remember the connection between T2 and T1 because of the induction, because of the self-induction, or you can say induction. So it is called induction coupling. T2 and T1 are connected by induction coupling. So this coupling, induction coupling, work as the feedback, that is called positive feedback. Whenever the current decreases, it sends a signal to increase the current or something. You will see that. Now, this is regarding the construction. So working, how it works means whenever switch S is turned on or it is closed, whenever this switch S is closed, current starts flowing through the collector emitter junction. When the current starts flowing through the current emitter junction, so here you can see in the beginning positive charges are start collected to the upper plate of the collector. Positive charges are start collecting to the upper part of the collector. Now, as the current go on increasing, as current does not increase suddenly, it gradually increases from 0 to maximum. When current start increases through this T1, so try to remember here, when current start go on increasing here T1, so magnetic flux linked with the T2 also changes. Hence, due to the self-induction, or you can say due to the induction process, there is a current induced in the T2 coil, or you can say base emitter junction. Right? So I will show by diagram here. See, first when switch is off, switch on, current start flowing through this. So current is reaching from 0 to maximum. So let me take 0 to maximum. Let me take this is a 0 current and it increases from 0 to maximum. So due to change in current, flux linking with the coil changes. Hence, due to the self-induction here, or you can say due to the induction, current is induced in the coil T2 also. So this current is also increasing from 0 to maximum. So 0 to maximum. 0 to maximum level means current increases up to the saturation level. You know what you mean by saturation level or saturation current is. So current increases up to the saturation level. Once the saturation level or saturation current reaches the saturation level, when the current reaches the saturation level means there will be no increment, try to understand this point, there will be no increment in the current. Here whatever the current increase is taking place, no, there will be no change in the current, I can say. There is no change in the current. Due to change in current is 0, so there is no change in the flux linking with the coil T2. There is no change in the flux. So there is no change in the flux means there is no induced current. Getting my point? So if there is no current in this coil means current starts go on decreasing. So current go on decreasing means, so in the second, here I am writing this for T2 and this for T1. So current go on decreasing. So current go on decreasing. So as the current go on decreasing means, here current go on decreasing means, now you can see the flux linking with this coil is changing. Flux linking with this coil is changing means here due to the change in flux, here now the current is induced. So here now because of the flux linking change in here, the current is induced in the T1. So current is induced in T1 means now whatever happened is in the second cycle positive charges start accumulating in the lower plate. So you can see in the T2 as the current go on decreasing, change in the flux takes place. Change in the flux takes place. So that change in the flux leads, that change in flux leads change in current in T1. So that change in current in the opposite direction of previous current. So here you can see the current changes takes place. So further this cycle will continue like this. Further this continue. So amplitude of the current remains constant because whenever the current decrease takes place, whenever the change in current or decrease in current takes place, T2 makes it to increase like this. Whenever there is no change in the current, when the current stops, so it starts decreasing. Due to this decrement of the current decrement T2 takes place. That leads the change in the flux linking with the coil T1 and induce the current in the opposite direction. So current in opposite direction in T1. So this completes one cycle, I can say. Now further, once again flux linking with the coil takes place. Once again it reaches the maximum current and same process will be taken place. So this is regarding the overall study of the transistor as an oscillator. Hope you got some picture regarding this. So let us try to recall it once again. So here first you have to write regarding the definition of an oscillator. Oscillator is a device which produces undamped oscillation or undamped electromagnetic oscillation. So it is producing undamped electromagnetic oscillation. So whatever the device may be, if it is producing the undamped electromagnetic oscillations, that is called as the oscillator. So we have seen one example of oscillator, collector and inductor, where we are getting the damped oscillation, but we have to have undamped oscillation. Because of that, we have needed feedback circuit. So feedback circuit. That feedback, when it takes the signals from output and feed it to the, or you can send it to the input and make the output more stronger, you can say more brighter, then such feedback is called positive feedback. Such kind of feedback is used here in our circuit now. That feedback is done by, I'm naming it as the induction coupling. So remember this term, induction coupling. So now, first you have to explain the construction. After drawing this figure, you have to explain the construction. Construction says that the emitter base junction is made forward bias condition by passing through the inductor coil T2, and collector emitter junction is made a reverse bias by passing through a tank circuit. In the bracket you can write tank circuit consists of a capacitor and the inductor coil T1 in parallel connection, and a switch is provided to turn on and turn off the circuit. So you can say as shown in the figure. Now working as soon as the switch S is closed, or you can say it turns on, current starts flowing through the tank circuit. Tank circuit means the current starts flowing through the coil T1. As soon as the current starts increasing gradually, which makes the flux linking with the coil T2 changes, hence the current is also induced in the T2. And when the current in T1 reaches the maximum level, or its saturation level, there is no change in current, hence in the T2 coil current starts decreasing. That gives change in the magnetic flux, and due to that change in magnetic flux, one more time the current is induced in the T1 but in the opposite direction, what I have shown by the diagram. Then opposite direction. So this completes one complete cycle. Then furthermore, the same process takes place. Current once again reaches the maximum level. Here flux changes once again. So this cycle goes on repeating. So this is regarding the transistor oscillation. Transistor as oscillator. So hope you have got the clear picture, and just take out the screenshot and follow your notes, whatever the college has provided. It is very good notes. Just follow those and make your own notes so that you get the clear picture. So just take out the screenshot and make sure that you are